In the silent, sprawling darkness of the cosmos, there are monsters. Not creatures of fiction, but real, physical objects, whose power defies our everyday comprehension. We think of stars as distant, beautiful, life-giving beacons in the night sky. But some stars die, and in their death, they become something else entirely. Something terrifying. Something that, even from halfway across the galaxy, can reach out and touch our world in the most violent ways imaginable. We're about to journey to the most extreme, most dangerous, and most magnetic objects in the entire universe. We're going to explore the celestial horror that is the Magnetar. Welcome to Astronomical Library. Imagine an object so powerful, it could theoretically wipe the data from every credit card on Earth. From over 100,000 miles, away nearly halfway to the moon. Now imagine that same object could rip you apart, atom by atom, from about 1,000 kilometers, or 600 miles, away. This isn't science fiction. This is a Magnetar, the deadliest star in the universe. And in this video, we're going to journey to the heart of one of these celestial monsters to understand the terrifying science behind them, and what would happen if one ever turned its attention toward us. So, what exactly is a Magnetar? The name itself sounds like it's been torn from the pages of a comic book, a cosmic supervillain. The reality is, somehow, even more extreme. A Magnetar is a type of neutron star, but calling it that is like calling a great white shark a fish. It's technically true, but it misses the terrifying point entirely. Let's start with the basics. A neutron star is the collapsed core of a massive star that has gone supernova. It is one of the densest objects known to exist. Imagine taking a mountain, something like Mount Everest, with all its rock and ice, and crushing it down until it fits into a single sugar cube. That's the kind of density we're talking about. A single tablespoon of neutron star material would weigh over 100 million tons. These are city-sized spheres, maybe only 20 kilometers, or 12 miles, in diameter. Yet they contain more mass than our own sun. Many neutron stars that we observe are known as pulsars. They spin incredibly fast and sweep beams of radio waves across the cosmos like a lighthouse. They are fascinating, but they are not Magnetars. It's important to remember that all pulsars are neutron stars. But not all neutron stars are pulsars. Some are too old, or their beams just do O&T point our way. A Magnetar is a neutron star that has been twisted into something far more sinister. They're born from the same stellar death, but a specific, violent set of circumstances forges them into the universe's ultimate magnetic titans. While a typical neutron star has a powerful magnetic field, a Magnetar's is on a completely different level. Our planet Earth has a magnetic field, which is vital for life. It measures about half a Gauss. A common refrigerator magnet is about 100 Gauss. A powerful, hospital-grade MRI machine might generate a field of 30,000 Gauss. A typical pulsar's magnetic field can be 1,000,000,000,000 Gauss. That's already a mind-boggling number. A Magnetar's magnetic field starts at around 100 trillion Gauss and can reach 1,000,000,000,000 Gauss. That is 1,000 trillion times stronger than Earth's magnetic field. It's a number so large it's difficult to assign any real-world meaning to it. It is the strongest magnetic field known to exist in the universe. This field is so intense, it fundamentally alters the laws of physics around it. In the environment of a Magnetar, the vacuum of space itself is warped. Atoms are stretched and distorted into long, thin needles, unable to keep their normal spherical shape. Chemistry as we know it simply ceases to exist. Molecules can't form. They'd be instantly ripped apart by the sheer magnetic forces. If you were to get within about 1,000 kilometers of a Magnetar, your body's own bioelectric field, the tiny electrical signals that make your heart beat and your brain think would be scrambled. The very atoms that make up your body would be stretched and torn apart. You would be disintegrated, not by heat or radiation, but by the raw power of magnetism. This isn't just a dead star. It's an active, magnetic behemoth. A zombie star whose magnetic corpse is far more dangerous than the living star ever was. And unlike pulsars that spin rapidly, Magnetars rotate much more slowly, typically completing a rotation every 2 to 10 seconds. This slow spin is a crucial clue to their nature. They aren't powered by rotation like a pulsar. They're powered by the decay of their own impossibly strong magnetic field. And this decay is what makes them so active, so violent, and so very dangerous. So, how does the universe forge such a terrifying object? What kind of cosmic crucible can create a star with a magnetic field powerful enough to tear apart matter itself? The birth of a magnetar is one of the most violent events in the cosmos, a perfect storm of mass, spin, and chaos. It all begins with a star, but not just any star. Not a star like our sun. We're talking about a true giant. A star at least 10 to 25 times more massive than our sun, with some theories suggesting the progenitors could be as massive as 40 solar masses. During its life, this star rages against the darkness, but all stars must die, and for a star this massive, death is a cataclysmic explosion, a supernova. When the star runs out of fuel, its core can no longer support the crushing weight of its outer layers. In a fraction of a second, gravity wins. The core collapses with unimaginable force, and the outer layers are blasted outwards in an explosion, so bright it can briefly outshine its entire galaxy. What's left behind is the crushed, hyperdense remnant, a protoneutron star. Now, for a magnetar to be born, something special has to happen. The key ingredient seems to be spin. The original star must have been spinning incredibly rapidly, as its core collapses from a sphere millions of kilometers wide down to just 20. The law of conservation of angular momentum dictates that its spin must increase, dramatically, just like an ice skater pulling their arms in. This newborn protoneutron star is spinning at an insane rate, perhaps even up to 1,000 times per second in some theoretical models. This, combined with the churning plasma of the star's interior, creates the perfect conditions for a dynamo effect, a process where motion is converted into magnetic energy. In a protoneutron star, this process is amplified to an almost unbelievable degree. One of the leading theories, known as the Taylor's brute dynamo, suggests this process forges the magnetar's colossal magnetic field. Advanced simulations are now confirming that this dynamo, supercharged by supernova material falling back onto the newborn star, can amplify the star's magnetic field by a factor of trillions in just the first few seconds of its life. This process is incredibly chaotic. So much energy is poured into the magnetic field that it dramatically slows the star's rotation. This is why magnetars spin so slowly compared to pulsars. All that rotational energy has been converted into pure magnetic power. However, recent research suggests this might not be the only way to build a monster. Some magnetars, like SGRO 50144516, have been found far from the massive star-forming regions where supernova typically happen. This has led to another terrifying theory, that some magnetars might be born from the merger of two smaller neutron stars, or a white dwarf in a binary system that steals enough matter from its partner to collapse. The idea that two of these incredibly dense objects could collide and create an even more extreme one just adds another layer to their violent origins. No matter how it forms, the result is the same: a star just 20 kilometers across, with a magnetic field so powerful it dictates the very nature of reality around it. It's a cosmic anomaly, both rare and short-lived. A magnetar's magnetic field is so strong that it's unstable, decaying over a period of about 10,000 years, a mere blink of an eye in cosmic terms. And it's this decay that powers its terrifying outbursts, turning it from a static object into an active, unpredictable threat. A magnetar isn't a sleeping giant. It's an active, twitching monster. Its immense magnetic field is a tangled, stressed cage of energy. Sometimes, that stress is too much. The field lines shift and reconfigure in violent, sudden events that can cause the solid crust of the neutron star thought to be 1,000,000 times stronger than steel to crack and shift. This is a starquake. A quake on Earth can be devastating. A starquake on a magnetar is a cataclysm of cosmic proportions. The sudden reconfiguration of the magnetic field can, in a fraction of a second, unleash more energy than our sun will produce in 100,000 years. This energy is blasted into space as high-energy X-rays and gamma rays, the deadliest forms of light. Most of the time, these flares are relatively small, though small, in magnetar terms, is still monstrously large. but on rare occasions, a magnetar unleashes a giant flare. To date, we have only observed a few of these events from magnetars in our galactic neighborhood. SGR 1806-220 is on the far side of our Milky Way galaxy. About 50,000 light-years from Earth, that is an immense distance. The light from this event began its journey toward Earth when Neanderthals still walked our planet. On that day in 2004, SGR 1806-220 had a massive starquake. For a single tenth of a second, the resulting flare was intrinsically brighter than every other object in the night sky combined. It released more energy than our Sun does in 250,000 years. The wave of gamma rays stormed across the galaxy. 50,000 years after it started its journey, it slammed into the night side of Earth. Even from that staggering distance, the effects were immediate. The burst of radiation was so powerful it partially ionized Earth's upper atmosphere, the ionosphere. This is the layer radio operators use to bounce signals around the world. For several minutes, radio communications were disrupted. Satellites in orbit were blinded, their sensors completely overwhelmed by the flood of radiation. Many automatically shut down to protect themselves. This wasn't a near miss. It was a direct hit from halfway across the galaxy, and it was powerful enough to physically affect our planet. Think about that for a moment. An object so far away, it's barely a speck in our most powerful telescopes, had a direct, measurable impact on Earth. It was a wake-up call for the astronomical community. The threat from magnetars wasn't just theoretical anymore. It was real. We had seen it. We had measured it. We had felt the faintest touch of a monster's hand from 50,000 light-years away. And it forces us to ask a chilling question. What would have happened if it were closer? The 2004 event was a shot across the cosmic bow. It proved that magnetars are a credible, if distant, threat. So, let's indulge in the cosmic horror scenario. What would happen if a magnetar wandered into our neighborhood? The threats are twofold: the magnetic field itself and the radiation from a flare. Let's start with the magnetic field. As we've discussed, if a magnetar got to within around 1,000 kilometers, its magnetic field would destroy you on a molecular level. But you wouldn't need to get that close to feel the effects. A magnetar could wipe a credit card from a distance of over 100,000 miles. If one entered our solar system, the chaos would begin long before it reached Earth. Its immense gravity would destabilize the orbits of the outer planets, potentially flinging comets from the Oort cloud into the inner solar system and disrupting Earth's own orbit. But the magnetic field would be the true killer. Long before it got close enough to rip us apart, its field would wreak havoc on our technological civilization. It would induce massive currents in our power grids, blowing transformers and causing continent-wide blackouts that could last for years. Satellites, the backbone of global communication and navigation, would be rendered useless, their electronics fried. But the most terrifying threat is a giant flare. We saw what SGR 1806-20 did from 50,000 light-years. Let's shrink that distance. If a magnetar were to have a giant flare just a few thousand light-years away, the consequences would be catastrophic. The initial blast of gamma radiation would be powerful enough to severely damage our planet's ozone layer. Without it, surface life would be exposed to lethal levels of UV radiation, leading to mass extinctions. The blast would also compress Earth's own magnetic shield, leaving us even more vulnerable, and could trigger chemical reactions in the atmosphere that might darken the skies, causing a global impact winter effect that would collapse the food chain. All of this from an event happening trillions of miles away. And what if a flare happened even closer? Say, 100 light-years away. At that range, the conversation changes from ecological disaster to outright extinction. The gamma-ray burst would likely be powerful enough to boil away the upper layers of our oceans and atmosphere. They would effectively sterilize the surface of the Earth, wiping our planet clean. It would be an instantaneous, planetary-scale catastrophe. The saving grace, if you can call it that, is that magnetars are incredibly rare. There are only about 30 confirmed magnetars in the Milky Way, although some scientists speculate there could be many more dormant ones. The closest known magnetar to us is an object called XTEJ 18102-197, located about 8,000 light-years away, which has recently shown some strange and unprecedented radioactivity. Others are at similar distances. They are all, for now, at a safe distance. But the universe is a dynamic, moving place. And the suddenness of a flare is perhaps the most unnerving part. There is no warning. The light from the flare travels at the speed of light, so we would have no advance knowledge it was coming. It would simply arrive, a silent, invisible tsunami of energy from the depths of space. Exploring these cosmic monsters reveals just how extreme and awe-inspiring the universe truly is. The physics of Magnetars pushes our understanding to its absolute limits. If you find this journey into the terrifying heart of the cosmos as fascinating as we do, make sure to subscribe and click the bell icon. We're constantly exploring the biggest questions and the most extreme objects in the universe, and you won't want to miss what we uncover next. Also, let us know in the comments, what other cosmic horror would you like us to explore? Black holes, rogue planets, the Great Filter. Magnetars are a profound and humbling reminder of our place in the cosmos. They are the universe's ultimate expression of magnetic power, forged in a dying star's final, violent moments. They are objects so extreme they defy our intuition and force us to confront the fact that the universe is not always a serene and beautiful place. It is filled with violence, with power, and with forces that could extinguish a world in the blink of an eye. From the impossible density of their interiors to the terrifying reality of their Starquakes, Magnetars represent a frontier of physics we are only just beginning to understand. Every flare we detect, every new Magnetar discovered, gives us another piece of the puzzle. Recent discoveries have provided strong evidence linking Magnetars to at least some of the mysterious fast radio bursts, FRBs, that flash across intergalactic space, suggesting these objects have even more secrets to tell. We're learning that the energy stored in their magnetic fields can be twisted and reconfigured, releasing radio waves that we can see from across the universe. The threat to Earth is, for now, theoretical. The odds of a Magnetar wandering close enough to harm us, or a giant flare from a nearby one being aimed directly at us, are infinitesimally small. We are safe. But the 2004 event proved that we are not isolated. We are part of a larger, interconnected cosmos, a galaxy filled with wonders, but also with monsters. And in the grand silent theater of space, the deadliest star we know of is out there, a sleeping giant, powered by the most extreme force in the universe, waiting for its next Starquake to remind us just how powerful the dark can be.